Welcome to today's notes on LeChatelier's principle. LeChatelier's principle says that when an equilibrium system is stressed, it will shift position to counteract that stress in order to reestablish the equilibrium. What that means is that when an equilibrium system is changed in some way, or the conditions of that equilibrium change, the equilibrium shifts in order to reestablish the value of K, or to be at equilibrium again. So the types of stresses that you can have are adding a substance to increase the molarity. You can subtract a substance to decrease the molarity, and when you're doing that, what you're really doing is you're reacting one of the parts of the reaction with something else. So it still seems like you're adding something, but you're not adding part of the system itself. Changing the pressure, and you change the pressure by changing the volume, and changing the temperature. So by adding a substance, I'm increasing the concentration of one part of the system. So if I have A plus B is in equilibrium with C, then I would have an equilibrium constant. The expression for that would be the concentration of C over the concentration of A times the concentration of B. So if I add more A to this system, then that's going to then my K value will no longer, or my equilibrium expression will no longer equal this K value. In order to reestablish equilibrium, this ratio in the equilibrium expression has to equal this K value again. So to do that, I would have to decrease the denominator and increase the numerator. So what will happen is that the forward reaction speeds up, and what that means, that's termed that the system shifts to the right. And by shifting to the right, I will increase the value of C, decrease the value of B. And A will be actually a little bit larger than it was to begin with, but it'll be smaller than when you initially added that extra amount of A. So by adding more A, the system shifts to the right towards the products to reestablish equilibrium. Second example. If I have iron 3 ion plus thiocyanate ion in equilibrium with iron 3 thiocyanate, then my K expression is going to equal concentration of FeSCN3 divided by the concentration of Fe3 plus times the concentration of SCN minus cubed. So which substance increases if Fe3 plus is added? So if I add Fe3 plus right here, right, I add more of that, then this here is going to be bigger, making the denominator bigger, and the equilibrium expression again will no longer equal K. In order for it to equal K, I need to increase my numerator and decrease my denominator. So by increasing my numerator, I will increase my FeSCN3 plus. So it has to shift right again. And that will increase my FeSCN3 plus, FeSCN3. So the FeSCN3 increases. So the generalization that we can make about adding a substance is that the system will shift to the side opposite of the substance that is added. So if I added more C over here, it's going to shift to the left. If I add more B, it's going to shift to the right. So you need to highlight this in your notes, that the system shifts to the side opposite of the substance that was added.
Now if you put a lot of sugar in your coffee, stir until it's sweet as it can be. You look down deep near the
First, we'll observe the effect of changing the concentration on the equilibrium. The equilibrium that we'll study is one of dichromate in equilibrium with chromate ions. Dichromate is orange in solution, while chromate is yellow. We'll observe the effect that adding HCl and adding OH- will have on the system.
Dynamic equilibrium, dynamic equilibrium. When the rates of two opposing reactions are the same, dynamic equilibrium.
Removing A, what happens is going to happen if we remove A? Well, let's start out by looking at our K expression. K is equal to the concentration of C times the concentration of A times the concentration of B. So if I remove A, that's going to make A smaller. So we're going to decrease our denominator. That means in order for this number, that means our value here is going to be too big. So we need to make K smaller. Or our ratio needs to be smaller to equal K. So in order to make that smaller, we need to decrease our numerator and increase our denominator. So remember, we have products in the numerator, so that means we need to decrease our products and increase our reactants. In order to do that, that means that our reverse reaction has to become dominant. And the reverse reaction is pointing left, so that means that it shifts left. So the generalization that we can make is that the side of the system that has the removed substance is the side that the system shifts towards in order to reestablish equilibrium. So again, we should highlight this in our notes. We add a substance, opposite side. We remove a substance, same side.
So let's get back to that coffee cup. Nothing's going on, but wait. At the surface of the sugar, molecules dissolve and recrystallize at the same rate.
In the first example, we added H+, which increased the concentration of the H+ ions in the equilibrium. This stress caused the equilibrium to shift left. Next, we added OH-, which reacted with the H+ and lowered the concentration of the H+, causing the equilibrium to shift to the right.
Now what happens if we change the pressure? Well, first of all, the way that we change the pressure is by changing the volume. You're not adding other gases, it's just only by changing the volume. And so just a quick reminder that if we increase the volume, that means we decrease the pressure. And if we decrease the volume, that means we increase the pressure. And that's Boyle's law from our gases unit. So when volume increases, pressure decreases, and vice versa. So what happens then is that the system is going to increase pressure in order to reestablish equilibrium by shifting the side with more moles of gas. A plus B is in equilibrium with C. We have 2 moles of gas here and 1 mole here, and these are both our gases. They actually have to be labeled gas because if it was a solid or a liquid or aqueous, it wouldn't act the same. So if we have 2 moles on the left side, 1 mole on the right side, then if I increase my volume, that means pressure decreases. If pressure decreases, the system will shift to add pressure. And in order for it to shift to add pressure, it's going to shift to the side with more moles of gas. So it will shift to the left over here, where there's 2 moles of gas versus the 1 mole of gas in the products. So when the volume decreases, pressure increases. So what happens then is, if we have A plus B gas is in equilibrium with C gas, then we're going to have the system, so pressure increases. That means the system will shift to decrease the pressure. And when it shifts to decrease the pressure, that means it's going to go to the side with less moles of gas. So the system decreases pressure to reestablish equilibrium by shifting to the side with the least moles of gas. So let's look at an example. Which way does the system shift if we have 3A gas plus 2B gas is in equilibrium with 4C gas when the volume is increased? So if the volume is increased, that means pressure is decreased. So in order for the system to reestablish equilibrium, it has to shift to increase that pressure again. More pressure equals more moles of gas, so we need more moles. So over here we have 5 moles of gas total. Over here we have 4, so it's going to shift to the side with more moles. The side with more moles is the left side, so it shifts left. And what happens when volume is decreased? When volume is decreased, we know that pressure increases because of Boyle's law. So that means it's going to shift to decrease that pressure, which means it's going to be the side with less moles. And in this case, the side with less moles is the right side. And the last way,
we have a mixture of NO2 gas and N2O4 gas compressed in a syringe. We're going to expand the gas quickly. The color initially gets lighter due to the decrease in the concentration. However, if we watch the gas for a moment, the color becomes darker as more NO2 gas forms. If you decrease the pressure on a gaseous equilibrium, the equilibrium shifts to the side with more moles of gas, in this case to the side of NO2.
that we can stress a system is by changing the temperature. So changing the temperature depends on the reaction being endothermic and or exothermic. So how do we change the temperature, or how does this affect the way the system shifts? So if I have the reaction A plus B is in equilibrium with C, and I know that it's endothermic. Well, endothermic means that energy is absorbed, and if energy is absorbed, that means energy is being treated like a reactant. So energy goes on the reactant side. So I would rewrite my equation. Energy plus A is in equilibrium with B plus C. So if the temperature increases, that means energy increases. If energy increases, that means we increase a reactant. Means we increased our reactants, And when we increase our reactants, that means it shifts opposite, so it shifts to the right. Now, if the temperature decreases for an endothermic reaction, it means energy decreases. That means we've decreased a reactant. And just like before when we were adding and subtracting substances, if we decrease something, it shifts to that same side. So that means it's going to shift left. Now, what about exothermic processes? Exothermic processes, remember that energy is released. And if energy is released, then that means we're treating energy like a product. So I have energy written on the product side over here. I'm going to rewrite my reaction. So this is a different reaction than the previous one because it's exothermic now. And if temperature increases, that means we are adding energy. And if we are adding energy, it means we are increasing our products in this case now. And when you increase a substance, or when you increase part of a reaction, then it will shift opposite. So that means it will shift to the left in this case. And if temperature decreases, it means you are removing energy. And that would be, in this case, because energy is a product, it's going to be the same thing as decreasing a product. So when you remove something from a reaction, it shifts to the same side. So that means it will shift to the right. If you have any questions, please feel free to rewatch the video and ask questions of your classmates. And good luck with your worksheets.
Next, we will try to determine if an equilibrium is exothermic or endothermic. The equilibrium we'll study is the equilibrium N2O4 in equilibrium with NO2. N2O4 is colorless, while NO2 is brown. We'll observe this equilibrium at 3 different temperatures: at a high temperature, at room temperature, and at a low temperature.
Now LeChatelier had a principle, and I don't mean the head of his school. He observed chemical reaction.
As observed by the increased intensity of the brown, increasing the temperature shifted the equilibrium to the right. This means that heat is a reactant, and the equilibrium was shifting to the right in order to use up the excess heat. This was confirmed by the decrease in temperature when the equilibrium shifted left, trying to replace the heat that was lost. Therefore, the reaction is endothermic, and the delta H is greater than 0.
Dynamic equilibrium, when the rates of 2 opposing reactions are the same. Dynamic equilibrium.